Okay, so I guess probably more people won't come. We waited 5 minutes, that's enough. So let's start with our next big int functionality. This is ready. So we already added the ability to convert the to and from textual representations of the numbers. So the next good thing to implement to our big integer would be some operators, so that we can not just use them to represent large integers, but also that we can do math with them. So we can start with the basic operations, and a convenient way of doing it would be first to write a function which does the actual operation, and then wrap that in a call from the operator. Since with the operators we will have usually more than one variation, at least two, like one for constant, one for non-const case. So it's nice if we have a function that does that independently, and then we can nicely make our explicit call interface to it. So I think a simple thing to start would be addition and subtraction. So who would want to write the first function that does any of those functions? Okay. Are you connected? Mm-hmm. So we need a function that takes as an argument a const c big int, or you can write the operator directly if you want. The function is const itself, and it returns a c big int on its own. So it creates a new instance of our number, and then the new instance will contain the sum of the current object plus the object passed to it as an argument. Yes? And then square brackets, and then you can write the argument like with a normal function. Square, not square. Round. Oh, sorry. Yeah, as reference is fine, and then just call it other. So if we have two arguments, it would be customary to call them left and right if you have like a comparison operator. But if we just have an operator that does something on the current object and a new and an additional object, then it's customary to just call it other. And you can make the function of type const, so that it can be also called on a const object, since it does not modify the current the current object. Yeah, it depends how we want it to work. We could go with a simple approach where we just take the size of the biggest of the objects, and if we have a overflow, then we have an overflow. Alternatively, we could also then look into, if we detect that we have an overflow, that we then allocate, that then we make the object bigger, because if otherwise, if we would always make it bigger, then with every addition the array would get bigger, bigger, and bigger, and bigger. So what we could of course do is some in between approach, where we check if in both of the objects the highest bit is set, Or more generally, if the highest byte is used, and if it is not used, then it's fine, and if it's used, then we allocate one more. So then, if we do the same operations, we will not grow it unnecessarily, but we will know that we always have enough room for a overflow. Overflow or carry. Mm-hmm. Well, if you have enough empty bits in both variables, then you can be sure that if you have that you won't have a carryover basically. So one could try to see if we have enough room, if we get a carryover, that it will not be a problem. But as I said, we also can use realloc to make the array bigger if we see that we need more space. So we could do it like this. So we allocate by default just the bigger size of the two sizes. So we can use the stdmax function to get which one of the sizes is bigger. And it needs round brackets and then just two arguments. And we should cache the result in a variable such that we know. Although it doesn't matter, we can always check the value from result, so it's fine. Yes. We defined bit count as const? No, we didn't. We have to define it as const. Well, then the lowest, so the lowest index in the array will be the lowest significant bits. Mm-hmm. Not quite. M size is for the current object, but we should go with the size value that we get from that we have inside result, since we want to process all the data. Mm-hmm. I would suggest to create two temporary variables, one for the chunk from this object and one for the chunk from the other object, which will either contain 0 or a copy of the data of that chunk, assuming that the array, the data object still has data at this point. I think unset integer. Yeah, that's one way. I would have used that trinary operator and have everything in one line, but this is also fine. Mm-hmm. Mm-hmm. Yes. Uh, yeah, that's the question. Um, since we are writing this on a well, on the level of C and not accessing any CPU status flags directly, the best way of doing it will be to do it, let's say, experimentally. So what you can do is you can add those together and then check if the result. So just add chunk 1 and chunk 2 together, and then check if the resulting number is bigger than that at least one of the two numbers that you gave in. If it's smaller than the two numbers that you added, it means that you apparently have lost a bit somewhere at the top, and then you can set the carry to 1. I would calculate a new chunk directly and then use this for the comparison. I would not re-add the same values over and over again. That makes for better performance if we cache that. Nowadays, memory is so cheap and so much and so plentiful, while the CPUs are not really getting significantly faster, like 10-20% per year at best, which is not really the doubling every 2 years that was promised a long time ago. So it's better to waste memory than to waste CPU cycles. So if it's smaller than let's see. Well, if the result is smaller than any of the two elements, then it means that we lost a bit somewhere. So if it's smaller than this element, or it is smaller than other element, then it means that we need to set carry to 1. And we need a variable for the carry flag, of course, so something outside the loop. Yeah. Yes. Okay, that could work. Now we need to test it. Uh, that would be a good idea, yes. Um, yes, we can run into the situation where we would carry over 2 bits if we implement it like this, because assuming this plus, so this lm plus other lm um, would already result in one carryover plus the other carryover, that gives you 2 carryovers. Yes. Well, if both most significant bits are set, it will carry over one. If it will create one carryover, but if we enter the loop with already having one carryover, then we would need to push the bit, basically carry over two during the next round. Um, try it out. Try it out. I mean, just make. How do we do that? You can try to make it like target the case, not like make a loop that adds one until a couple billion. Just really create two numbers where all bits are set, add them together, and see what the result will be. Yeah. Yeah, probably if we have an unconsumed carry. Um, but I don't think you will that this way. By this means, you would detect a case where we have like two overflows in one go. Um, this would be good as a test whether there is overflow in the sense that we don't have enough room in our alloc data, and we would need to add one more chunk, which we can do later. But it will not catch the case where we have two numbers. Let's do a test case like this: two 64-bit numbers. Add them, which are all set to all ones. Add them together and see what the result will be. Because ideally the result should be uh, well, just one carryover, so one error message, but the content should then stay everything once. Or in this case, everything F, since we don't have the binary function. I think that was homework for the next time, so we don't have that yet. But we can just go with using our hex initialization. Yes, so you need 16 Fs to get a 128-bit number. Wait, no, that's not true. To get a 64-bit number. For a 128-bit number, I would need 32 Fs. But let's go with this. 64 bits should be enough since it needs two chunks. So we should be already able to to run into the case. And if this works, then you can just make it bigger by one chunk and see if that works still. We have 2 hex. It's in the last, here. Yep, I think we... Yes? We have not created one, that is true. We should first create a copy constructor and an assignment operator. We will potentially need both. Yeah, so let's do that quickly. Well, in this case it will be the copy constructor, but well, no, here we already use assignment. We will need both. Depends on the compiler. It may really make a difference. May I have the mouse for a second? It may really make a difference whether you have this or whether you would do it like this. So in this case, I would say copy constructor is fine, assuming that it takes a reference. Yeah, but well, the copy constructor is really one that makes a copy if you provided an object of the same type. And the assignment operator is explicit if you use assignments. But in my experience, it really depends on the compiler when it uses both or just one of them. If you are using, if you are initializing a variable, so then it depends on how they thought they could optimize the code best. So it might not be something that's specified. Mm-hmm. Mm-hmm. Chunk count m size. So our m size variable contains directly. Yeah. Mm-hmm. Yeah, that's everything. And then we need this assignment operator, which is pretty much the same, just that it has to delete m data if it's already set. It's a reference on C big int. Is it a reference? Try without reference. I think it's better if we just return a full copy. Yeah, just const c big int other. Yeah. Great, show me the code again. Did you add everything? Well, you forgot to delete the m data that we might have already, because there might be one in the current object. If we just use it somewhere along the line, then there might already be an m data initialized. We can have multiple assignments one after the other, so we need to add a delete m data. Ah, wait, alloc does that already. Then we don't need that. Then just maybe try. Let's first try with the reference as a return value for the assignment. That seems as it makes more sense. Yeah, and you need to return it, of course. Yes, yes. Okay. Now everything should be in there. Okay, let's run. Yeah, we have an issue. We are missing a one. Not where I would expect. I would have thought that it would have dropped something at the top, but evidently it's not the right result. And it's not complaining that it has a carryover. It should be complaining. Uh, Put a breakpoint, yeah, to we arrive at that. Okay, next step. Okay. Yeah. A second carryover. Yeah. Yeah. Well, the thing is, we don't want to modify neither this nor other, so we cannot like add this carryover to any of those. Um, One way we could do that is that before the code as it is now, so before the addition in line 52, we insert some code, and the code would check if there is so we could make a variable like again like res2lm or something, or temp let's call it temp elem, unsigned int temporary element. And we can assign it this element plus carry. Then we will need to check whether this in itself caused a carryover, because it might. So we need to check that for the temp element. Well, we should check this also for, so it should be two checks, because we are adding carryover as well. and we might end up in a situation where we have two carryovers at the same time. So we need to check, I think at least. We can check whether the second check is necessary, but I would just check whether the new element is also smaller than carryover, just to be on the safe side. Can this happen? It might happen. And if this is the case, then we set it to 1, and if it's not the case, then we set carry to 0, since we already consumed it. So we need the else case, carryover is 0. And now in the addition further down, instead of this element, we will just use the temporary element. No. We already added carryover at the beginning to the temporary element. Adding it again, yes. But you need to change it in the if. Yes? Okay, one more thing to change. The test should be wait, this element, not this element, but temp element. Since we're adding, yeah, here. Yep, that should be working. Let's try it out. At least it complained. But I'm still not happy that it has not. The result should be just FFFs. Why does it? Why did it clear the one lowest bit? Yes. Well, it should be all Fs. So the thing is, if we do the same operation just with int64 int1 null x, the nice thing about using the smaller chunks is that we can benchmark our operation and the result of our operation against how an int should behave. I would assume they can do that by default. Now let's just see what would be the default result. And normally it should be just all Fs because add. Okay, that I forgot to set it to. Okay, interesting. But it actually looks like it also. So, and do I remember how to make this work in hex? I don't. Percent x percent null sec 8 16. Okay, if that works, it would be nicer, since then we can stick to the same toolset. Otherwise, we can always do it with printf. Okay, but it also that seems to behave correctly. But why did the e got cleared? Is that really as it should be? Apparently. No, you're right. Yeah, yeah. Yeah, okay. Yeah, I think you're right. So it works fine. Let's quickly check that. So let's say we have. It's easy to get your head wrapped around something where. So we have all ones, one, 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 and now we want just to add them together. So 1 plus 1 gives 1 at the top and a 0 here. Yeah, and we are carrying a 0 each time. And then the whole thing repeats, and in the end we want to end up with 1, 1, 1, 1. Yeah. Okay, then perfect. Working as it should. Good. That was easy. So for the next candidate, the task will be do the same, just in reverse, i.e. implement subtraction. Okay. Mm-hmm. It's always a good start to copy something that does something similar to what one wants to do. I mean, the only things that will change will be, of course, you use subtraction instead of addition, and then the carry handling will get much more, or at least slightly more messy. Yeah, you can start without any carryover, and then see what happens. Yes, wait. Uh, it should be German. Wait. What was it? Shift Alt. You need two modifiers. What was it? No. Wait. I will find it out. No. One more combination to try. Huh? What? I think it was Control Shift. Wait. We can just see edit. Advanced. Makeup. Command section. Control K. Control. But it's just Control K. That's interesting. That doesn't work. Why doesn't that work? Yes, I remember. You need to hold down Control, and they may press K and then press C. Oh wait, huh? Control. Yes, it works. You need to press you need to. So if you mark it like this, it will make a multi-line comment. What was the KU? And if you mark it like this, it will make a lot of multi-line comments, and you need to hold down Control and press K and C quickly after each other, and K and U for uncomment. It's extremely anti-intuitive because you usually don't expect to use key sequences to generate shortcuts, but um, that's how it works. I mean, they had more things they wanted to shortcut than keys on the keyboard, so they apparently yes. Um, yeah. Yes. This should work. Yes. since it nowhere consumes carryover, then it will definitely complain after the loop. So we could comment that out as well for starters. It's really strange. I'm normally using the shortcut often when I do things myself, but when I had to explain it, I kind of like you have muscle memory, but you actually don't know what you do. You just think, comment the block, and your hands do the right thing. And if you then have to think about what you actually press to do it, it gets complicated. It's really convenient to be able to comment out whole code blocks. I mean, the nice thing about C that you don't have in other languages is that you can in fact use the preprocessor to disable code blocks as well. I do that also a lot because the nice thing is that the code block you cannot comment out a code block easily if it has multi-line comments unless you comment it out as a lot of single line comments. Then it ignores the multi-line comment that you commented out. But if you use that would be good. If you use the preprocessor, then you can really disable any valid code block very efficiently. You could just make EFF, both of them EFF. Yeah, for starters, why not? Well, you are subtracting the... yeah, right, one should be different. Yes. 0 is fine. Yeah, but now you will be triggering the overflow intentionally. Good. If you would swap them, if you would just swap the order, makes f minus e, then it will correctly return you a 1 0 0 0. Wait, correctly, yes, and the f is the underflow in this case. It is similar, just that you need to subtract the carry from the temporary object instead of adding it to it. Mm-hmm. Now we need to change it such that we will again get an overflow. So so int 1 minus int 2 in both cases. Just a matter of exercise. That works at some point. Mm-hmm. Well, let me think about it. Technically, that will complain always because we are not consuming it. What we you should you should try to make a carryover. No, here. No, here it will not make a carryover. You need to make a carryover in the boundary between the two chunks. So, in the second half of the string. No, you need more. You need so you need to have your overflow happening in the first 8 nibbles from the right, such that it needs to be carried over to the second chunk. If you have your overflow in the second chunk, then it just stays there unhandled and creates an error message. Okay, so wait, may I? So let's just undo everything. Okay, so let's go for FF again, and so 1, 2, 3, 4, 1, 2, 3. Okay, this would be the last. That's the right thing. So this is like the first chunk. This is the second chunk, and that's the last nibble of the first chunk. And then we do the same thing here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. It should be carried, but it will, since we have not yet finished the code, it will probably do something strange. Okay, you can run it. Yeah. We that was not supposed to be zeros. Although wait, did that work? Did that work? Why did did we subtracted the right? I'm sure we can provoke an error with the right values. Wait, how much code did we have? Do we already have everything that we need? Okay, yeah, we have a lot of code, so we are technically doing most of the things. Did we change this? So here, wait, but this part was not changed. So here is still the wrong comparison, but it's still working. Interesting. I mean, we apparently did not run the situation where we would have two carryovers. That's why it didn't fail. Can we make that somehow fail? I mean, what we can do is we can I can change the whole thing into a. We can define it. Let's do it like this. Chunk type. For now, we might make it unsigned int, but then we will change that later into something else. And then we will just change it into a 16-bit number. Let's see, do we use int? Okay, so here we need it. Here we need it. Oops. And here to just search for size of. Okay, the one here. Okay, and times 4 is also not right. Wait, is it? Not for this one it is right, because we have 4. Wait. We have 4 double. Yeah, okay, here it's fine, but here it's not. Here it should be size of int. Okay. Not here, it also needs to be changed. And from hex size int n equals 3. Okay, that should be then -1. Okay, I think that's everything. So first of all, let's uncomment this part and test whether addition still works. Plus less. Yeah, we can comment this out. Let's go with this 1 plus 2. Yeah. And no, it's not quite what we wanted. We wanted just FFs, to add FFs together. Oops. Oh, yes. Okay. Okay, so well, this should work since we technically didn't change anything yet. Yeah, it says there is a carryover and it did the right thing. So now we change this down to shunt. That's 2 byte. And let's see the result. Interesting. Something failed big times. I guess somewhere we forgot just search for 4. This one here. Size of they call it chunk type, yes. Okay, any more 4s? Wait, wait, no, that's the percent 32 is also wrong. Wait, why do we do that? E times 4 to get the offset. Yeah, we need to times 8. Is this everything? Okay. Let's try again. Okay, we somehow have an issue with the from hex function. Okay, let's go through it one step at a time. So we allocate the right size. No, size is in bits, so this times 4 was correct. Wait, was it? Yes. Because this is in bits what we provide here, I think. Length. Yes. Okay, so this was right. Divide by 8 looks right as well. Hex. Okay, let's try it out. Well, it better, but not good. Okay, so the size is now definitely right because the hex string, every character in the string is 4 bits. That's correct. We make the right size, so this is correct as well. Now we go for the whole thing. We get a character, get a digit, and then probably here this is still screwed up. So what do we want here? We want the right index within our. Okay, so this times 4 was actually correct because we increment by 4 bits on every go through, and then we want the number of bits in the chunk which is correct. So now it should work. Unless I forgot something. No, damn it. Divided by 8. Let's just data is of the right type, yes. Oh, I think wait. No, this is also fine. 8, this is fine. Okay, let's just step through it and see where it starts to fail. Let's make a breakpoint here. Okay, so first offset is 0. We have only one loop. Okay. Wait, where do we getting the digit offset chunk? Where do we get chunk E? we divide e by 8. Is that correct? No, it's not. That's a problem. We need to divide this by size of this times, was it times 2? Let me think. So 8, because we had, so it should be 4. It's times 2 is right. So and let's see if it now works. Yep. Okay, so we have fixed what we broke, and now we can try the subtraction. Let's just go back here to our initial configuration with the, wait, what did we want this? I think we wanted this as the best. Yeah. Now let's see whether the subtraction will work. Yeah, here we have an error. So now we need to fix that. It's from the carry, so we... Yes. Mm-hmm. We will see. No, it did not. Yes. This is probably wrong. Yeah. Well, you could just test whether this is true and whether carry is not 0. And you need to put it in brackets, since yeah, we want no, we want this end test to only apply to the second OR condition. No, I would not bet on anything without brackets. Just put this in brackets to be on the safe side. Let's see. This it's let me think. This element minus carry, that sounds right. New chunk, this element, that sounds also right. Temp element. Temp element cannot be bigger than this element if carry was 0. So if carry was 0, this would not be true anyways. Well, we could put a breakpoint and step through it step by step and see what's really breaking. Because as this stands, I have no idea why this does not work as it should. This is fine, this is fine. Yeah, just run it. And then just compare what we see, what it's doing with what we want it to do. I'll set one option that may I have the mouse for a moment? Debug is already set. Where was it? No, here I think. No, where was that setting? Damn it. There was one of those fields had an option to add a button called hex, which then allowed you to switch between hexadecimal and normal representation. It should be somewhere around the here it is, around the debug. So if we now press it, then you see this as hex, which makes it easier to see changes. Because like if you change one bit, the decimal representation, the whole number can change, while here only one letter will change in the representation. Okay, continue. Yeah, that's right. That's 0 because we... Yeah. Okay, next go through. Now we should have a carryover. It won't change since carryover was 0, so it will not do anything. It stays 0. Yeah, let's see whether it says carry to 1. It does. We keep the carryover for the next go through. Doesn't make a difference. This became... Okay, wait, let me have the mouse for a second. So other element is FF and FFE. Because we removed 1, so it becomes FFF. Is that what we want? FFF, FFE. If we subtract 1, that should have became... Wait, if we subtract this, that doesn't sound right. I think we have here a underflow in the operation as such, because we subtract. Let's see, hex. So the temp element one was FFE. FFFE minus FFFF. Well, it just makes it negative, but yeah, so we get a bigger number. Okay, so then this should be true, which it is, and then it makes carry over 2. Okay, so let's say that this is correct. So we had 2 carry over. No, but we have 0, so we should be able at some point to subtract without losing anything. So carry over is now... we resetted it. That might be the problem. No, we have subtracted it, so now it's fine that we resetted it. Then we are at the same position. Carry over, and the next go through should be the one. We didn't make it the last one. We should have one where we had a chunk which starts with 0. I have not seen that yet. That probably will in the end be the error. Let's just... So 1, 2, 3. Okay, now that's the right chunk, and we have a carryover of 2. So this becomes yeah. Make it 1 again. Wait. Why do we need a carryover again since we have okay, but let's ignore this carryover. Then here d minus yeah. Yeah, let's try it again. So one, 2. This is the last go through. We start with a carry. We have an element. We subtract it, and then we get that is incorrect. Yes. Wait, no, it has not updated it yet. No, the problem was the breakpoint because it has not updated the value yet. Now it's updated it, and it updated it correctly. So it subtracted 2. And now this thing is smaller than that thing. Well, temp element is... But if this is larger than carryover, and carryover is not... See, well, this is why it goes in here, because this condition is true. Maybe this condition is wrong. Could be. The temp element. Well, if the thing is, what we want to catch is if the temp element gets internally a overflow. But this we already check. Temp element is bigger than this element. But this just sounds wrong. Let's just comment this out for now and see how the code behaves. If that looks correct. So this was just wrong. At least it looks like it. Yeah, now it works. We can add more carryovers to test this. One here and one there. Now we should have a lot of carryovers, like in every chunk one. Let's see if this will work as well. 1, 2, 3. You don't have one here, we have here. Yeah, that looks correct. I don't see any E's that shouldn't be there. We can change, where's 2 hex? We can change this to use, we can change this to also produce smaller letters. That seems to be easier on the eyes. Yeah. Yay, it's working. So, so we get an overflow at the end. So, ideally, well, what would we do ideally? I mean, it becomes a negative number. In this case, there is no way around it. It just becomes, just wraps around. We could We could make the whole thing bigger by 1 and then make a negative number out of it. That might be actually interesting to do that. Basically make it into a big int, yes. But what we can do, what is easier, is the other case where we have. So let's make a. Let's copy this and make it to code blocks. So we want to keep the addition, and this should be just f's. Okay, so now we do addition. And if we do this, we will also get an error message that we get an overflow. Yeah, but here we could easily just make it bigger. Where was it? Where's the plus operator? Here. If this occurs here, we could extend the size of our result by 1 to make it a bigger one. And then we could just add whatever was in the carry there, so that we don't lose data. We just make a larger integer out of it. We could do that. And for minus, I mean, it would be nice to make. Ideally, we would want to have two new features to our big int, which ideally would be switchable. M can grow, or can grow. That looks better. And the other one would be signed, so that we can set whether we want a signed or an unsigned number, and whether we want to allow it to grow or not. So we can well, we can either make this an extra parameter which can be set, or we just add it as an optional parameter to the constructor here. Let's go here with something like this from hex. Okay, and here signed is signed. Okay, for the copy constructor, we just take the signed from the other one. Signed and the can grow. Wait, that's not a pointer, it's just a reference. So that's for this, and that we will also need for the assignment operator. Yeah. Good. Can grow is signed, and we need a function. Signed can grow. We will also want to get out, and then we should also make this const and that const, so just that all the read-only functions are const. 2 hex can also be const, it doesn't change anything. 2 bin will be const once you've done that. Yes. Okay. And we could. Okay, this we have here already, and we need to. We need a set grow. Void set. Well, set can grow or set grow. What sounds better? It's not const, and or be set. Yeah. Too much auto formatting. Those look better when they're single line, but we can also assign a default parameter. Since by default it's set to wait, the constructor needs to set this to false as well. This one here, comma. Okay, nice. So we have this, we have that. So then the question will be what everything will change if we have signed and unsigned numbers. I mean, for the addition, nothing will change. So let's make some homework. Do. Yes. Signed means that the number can be positive or negative. That it just means that the highest order bit determines the sign of the number. Because we would then need to store a whole other byte and not just use one bit. It would be more wasteful memory-wise. And the other thing which we had in part 1 of the lecture last semester is that when we have things like here, that the object as such might end up being bigger than just the sum of these field sizes, because the compiler will add empty fields in between to facilitate a better memory alignment. So I mean this thing is 8 characters, this thing is 8 characters, this thing is 1 character, and this thing is 1 character. So at this point that probably will still be fine, but if we would have it like this, then the compiler would have added here 6 more characters, such that this one and this one are aligned to the 64-bit boundary. If we have the flags as the last ones, then it won't add, like here. There is no point in adding anything because we are not accessing this memory anyways. But if you would, for example, take this whole thing and then create another structure, my blob, and give to it a full instance of int, and then give it a void asterisk data, then here the it should not call it int, I should not call it in my int. Then here the compiler would throw in 6 empty padding bytes because of those 2 flags. Now of course here we can add as many as until this runs to 0 without wasting anything, but if we would have an implementation where we don't have these 2 flags, but we always assume that it is always signed and that it always can grow, then in this case we would not have any padding bytes and we would still be able to represent positive and negative numbers. So it's, well, I mean, we could of course add a flag that would indicate whether it's positive or negative as such. So an additional one, since we have free memory here, and there are implementations which do it like this, so that they really have like one field for the data and one flag separately. But I think for now, one feature that would be nice to have is that we can cast at least smaller values directly on an integer. So that's another reason why it is good to use one bit of the data. Currently, with our current alignment, we can just cast. So if we have an data which is smaller than 64 bits, we can cast it directly on a. So the memory there cast it directly on a integer or a short integer. So let me. Wait, why is this complaining? Because we don't have a default argument. This by default it's false because it's not implemented. But what we could do now, if we could do it, we can do it. It's not, I have not set it yet to private or anything. Yeah, it's commented out, perfect. So what we can do is, if we know, so if mdata size, no, let's make bit, get bit count is equals 64, then we can just int test is equals, so this is already an address, int 64 asterisk, and then dereference the whole thing in 64. So this one thing we can do, voila, it works, and it gives you a valid number. And this works the same way with signed and unsigned in 64. If we would have an additional flag, then we would need to add additional logic here to handle this case. And what we also can do, even without checking, so the other thing we could do, if this is smaller equals 64-bit, so the cast as done here, it will always take the whole data, and if we have less data, then that would not be good. But what we can do is we can initialize this to 0, then use memcopy. Source is mdata, and I think size was in chunk size, right? Let's add a byte count. Wait, that's one too much. Bit count. Get byte count, and we can then change our bit count to work like this. Okay, so, and in this case, any number that's smaller or 64-bit, whatever it is, can be directly consumed here by this int. Wait, haha, that's not really true. That will fail if it's a signed number. If it so this case works, but this case, since we are just copying it, we would leave the higher order bit 0, and it would lose the sign. So this would not work, in fact. But this is already a more sophisticated way of consuming the data than this one. So I would say for now we just stick with the idea of using just the highest order bit as a flag, and then what one could do if you have a smaller integer than 64-bit. Yeah, but this will not be elegant here in any case. We could add a function to pad it, so that it returns a copy that is extended to a given size, and then we could always take this case. So I will just delete this case, since this one is not foolproof. It only works for unsigned numbers anyways, but as I said, this one works for signed, and that's why we will stick for now to using the highest bit in our chunk. Do we need to change anything actually? Whether it's that we will need to change a few things. The nice thing is that in hex representation, there is no really a difference between the behavior, whether the number is signed or unsigned. But I'm thinking what we want to do with that now. So since we are running out of time, we just have 1 more minute. So maybe we should first think about some homework. So if we have can grow, then do something. Else not. So this will be homework number 1. Homework 1. Yeah. Okay, so this is one thing. Grow. result chunk by 1 if this is needed. Okay, and I'm thinking about this case. So if we have two numbers and they are the signed case is much more complicated, because first of all we would need to ensure that both have the same size, because we want the first flag to the highest order byte to be always the highest order byte. It might be really easier, at least for our use, if we really use a flag for that, for signed and unsigned. So yeah, I like the ability of casting, but it probably will be, for assuming we don't use this use case, it probably will be better for other use cases. Like, it will make allow us to have a less complexity in the code as such if we just have a separate flag negative. So let's just go with that. Let's go with that for now. Okay. I mean, this makes things easier. Yeah, let's go with this. There is a typo, probably. I'm known for. No, it's fine. I'm very much feared from producing an arbitrarily high amount of typos. Okay, but so negative then will be here an additional parameter, which we'll also set. So here and here. And wait, where's our copy constructor here? Okay. Yeah, and basically then you will need to do the right thing. So the next homework. To do. Let's call those homework 1. Okay, then let's call it homework 2. Well, and yeah, and you subtract appropriate, exactly. So if both are negative, then we can still do plus, and if one or the other is negative but the other is positive, then we need to use subtraction instead. And the same thing basically applies for the minus operation. Well, check if the subtract flag, and if you use and wait, check the negative flag and use addition instead if appropriate. Right, yo. So if both are negative, then no, wait. If both are negative, then we use just addition, and then here we could add basically a variation of homework 1. No, that will be homework 3. Because if this happens, then we ignore the can grow. Basically, we want to generate a negative number. So if this is signed, because if it's signed, then we can do it, then we can return a negative value. So wait, but if this is signed, then we can just make it a negative value. Then we don't need to grow it. Yeah. Homework. Oh. But we will need to grow that. If we subtract this the wrong way, then it will not only change the that gets too complicated. Let's stick with something easy for the homework. So for now we will only grow it and ignore the rest. And I will think about the rest in detail so that I can give you a nice homework assignment next time, instead of something that might end up to be too complicated. Okay, now so this goes. For now, this just returns, and I will just leave here a to do later. So we now just so for today there will be just one homework to grow this as appropriate, and I will think about properly how to the most elegant way to handle the signed and unsigned case, and that will be the homework that will be scheduled the next time. Okay, so we can comment this out as well. Well, that would be basically the normal signed behavior. So if we say that it can be signed, then it would do that. Let's quickly check that. So so we want to get a underflow here. So f minus ff. So to see that would, yeah, but it basically will end up complement anyways. But that signed or unsigned hex representation will always what is complaining about? I did not comment out everything that had to be commented out. Okay, so this what it did here, and if we go, but I think this case will already, yeah, I said it doesn't change the hex representation whether it's signed and unsigned. And now if we check our numbers here, zack, because I think that it will already operate correctly. It will just produce the error message, but I think it should. Yeah, as you see, our own code already basically does the same thing, just that it forgets that now the number should be negative. So and that it already stores it as complement. So there is nothing to do unless we would want to make the negative, to add this negative flag. I think it's enough if for homework for today we just have to grow this, and then we will see where to go from there, whether we want to have separate variables or not. I will try out whether this can be done somehow nicely, and if not, then the next time what we will implement will be multiplication and division, which is much more complicated. And what we also can implement will be a lot of very simple operators, like OR, XOR, invert, and bit shifts. But pretty much everything that we can do with integers. But since we are already 9 minutes over time, I don't want to hold you here for longer. We will look into what we do next time. And for now, as said, just this one homework here to grow our integer if can grow is turned on. Okay, so see you next time, or respectively see you later today for the lecture. Bye bye.